At t equals 0, the capacitor is discharged and the switch is moved from A to B. So below this is the circuit right here, A, B, and C. So at t equals 0, the switch is moved to B, so they close it. At t equals 6, the switch is moved to C. The switch is moved here. So the question is to find the capacitor voltage at t equals 0. So what formula do we actually have to use? Let's go to the, let me find the FE handbook. Alright, so here we're dealing with RC transient here. So we have this formula right here, V sub C of t is equal to the initial voltage at t equals 0 plus this formula right here. So let's write it down and figure out how to solve this problem. So let's write it down first. All right, so the question is to find a t equals 6. So let's say VC at 6 seconds is equal to VC of 0, initial voltage, e to the power minus t over tau, and tau is R times C, the resistance times the capacitance, plus, let's go back, I can't remember, V1 minus blah blah 1 minus E, okay, plus V voltage, 1 minus E to the power over R C. Let's double check again. Yes, looks like we got it correctly. Alright, so what do we know and what do we not know? I should have put here minus 6 because that's really what it is here, but to kind of be consistent, I should put t here just to kind of be consistent with the rest of the formula, but it should be V of 6, but if I put V of 6, I should put 6 here and 6 here as well. So VC of 6, that's really what the question is. So what's the initial voltage at t equals 0? At t equals 0, the capacitor is discharged, so voltage is actually equal to 0. So this, let me use a different color. So here it goes to 0 due to the fact that the capacitor is discharged. So you gotta know, you gotta read your problem carefully. So this is actually equal to 0. All right. So we're left with V 1 minus E to the power minus T over RC. So what's the voltage? The voltage is given as 50. One minus E to the power minus 6 over R. R is pretty much 51. Bright. Let me think about it just a little bit. Yes, so that'll be 51. Yes, that'll be 51. And the capacitance is 100 microfarad. 100 microfarad. So that'll be 51 times 100 minus 6 farads. So if you put that into your calculator, oops. All right, so we have VC of 6 is equal to 34.58 volt. Oops. All right, so at t equals 6 seconds, the capacitor voltage is equal to 34.58. So this is pretty much the that's the peak voltage the capacitor reaches actually before it starts to discharge, right? So we got to understand what we're doing here and understand the problem before we even start solving it. So the voltage that we just found right now is the peak voltage the capacitor reaches. So it reaches 34.58 volt before it actually starts to discharge. All right. So let me know if you have any questions for this problem. Thank you.